Imagine this. Right now, as you watch this video, something ancient is cutting through our solar system at over 130,000 miles per hour. Something that might be 7 billion years old. Something that's been traveling through the darkness of space since before our sun even existed. What if I told you this visitor is doing things we've never seen before? What if its behavior is so unusual that astronomers around the world are scrambling to understand what they're looking at? This is the story of 3I Atlas, and what's about to happen in the next few weeks could change how we think about what exists between the stars. Let me take you through this mystery step by step. The strange arrival. It started as a tiny speck of light moving against the background stars. Just another dot in telescope images. But when astronomers looked closer, they realized something was off. This wasn't a normal comet, not even close. 3I Atlas is only the third known visitor from beyond our solar system. The first two, Oumuamua and Borisov, were strange enough. But this one? This one's breaking all the rules in ways that have scientists genuinely puzzled. What if this object is showing us that everything we thought we knew about comets needs to be reconsidered? The backwards tail mystery. Here's where things get weird. Picture a normal comet. As it gets closer to the sun, ice turns to gas, dust gets released, and solar radiation pushes that material away from the sun. That's basic physics. The tail always points away from the sun. Always. Except 3I Atlas has a tail pointing toward the sun. Think about that for a second. This is like watching water flow uphill. It shouldn't be possible according to everything we understand about how solar radiation and pressure work in space. What if this backwards tail is telling us something fundamental about this object's composition? What if it's made of materials we've never encountered before? Scientists have run computer models trying to explain this. For dust to move toward the sun instead of away from it, the object would need to be venting material from its sun-facing side with incredible force. Enough force to temporarily overcome the solar radiation pushing outward. But here's the problem. When they pointed spectroscopes at 3I Atlas to detect the gas emissions that should be causing this venting, they found nothing. No detectable gas at all. Just dust moving in the wrong direction, with no visible explanation for why. The impossible size. What if I told you this visitor might be enormous? We're talking potentially 5.6 kilometers across. That would make it by far the largest interstellar object ever detected passing through our solar system. To put that in perspective, Oumuamua was estimated at just 400 meters long. Borisov was maybe 1 kilometer across. 3I Atlas could be more than 5 times larger than either of them, and it's moving faster too. 130,000 miles per hour through our neighborhood. What if an object this size, moving this fast, came from a star system completely unlike our own? What secrets from that ancient place might it be carrying? The unlikely path. Now let's talk about where this thing is going, because this is where the mystery gets even deeper. Imagine you're planning a road trip and you want to visit 3 specific cities that are hundreds of miles apart. The odds of randomly driving and accidentally hitting all 3 cities perfectly? Pretty much impossible. That's essentially what 3I Atlas is doing. Its trajectory brings it remarkably close to 3 major planets, Mars, Venus, and Jupiter, all in one pass through our solar system. In early October 2025, it passed within just 30 million kilometers of Mars. That's close enough that rovers on the Martian surface might have captured images of it in the sky. Later, it swings past Venus at about 0.7 astronomical units, still remarkably close in cosmic terms. Then, in 2026, it approaches Jupiter's neighborhood, coming within 0.3 to 0.4 astronomical units of the gas giant. What if this path isn't random at all? What if the statistical odds of naturally achieving this trajectory are so astronomically low that we need to consider other possibilities? Some astronomers have pointed out something fascinating. If you were designing a mission to observe multiple planets in our solar system, this exact trajectory would be ideal. You could release observation devices at each planet without needing to significantly alter your course or burn extra fuel. I'm not saying that's what's happening, but what if the universe is showing us that nature can create paths that look designed? The vanishing act. Here's where the timing gets suspicious. On October 29, 2025, 3I Atlas reaches perihelion. That's the point where it gets closest to the Sun. This is when comets typically become most active, brightest, and most interesting to study. But at that exact moment, 3I Atlas will be positioned directly on the far side of the Sun from Earth's perspective. We won't be able to see it. The Sun will completely block our view during the most critical phase of this visitor's journey. Hubble can't observe it. The James Webb Space Telescope can't observe it. Earth-based telescopes can't observe it. What if this timing means we miss the one chance to see what this object really does when it gets heated up by solar radiation? Some have wondered whether this positioning could somehow be intentional, designed to avoid detailed observation at the most revealing moment. But that raises more questions than answers. The more likely explanation? Pure cosmic coincidence. The universe doesn't care about our observation schedules. But either way, we're facing a blind spot at the worst possible time. The detective work scientists aren't giving up, though. What if there are ways to piece together the puzzle even without perfect visibility? Researchers have been working overtime, using every tool available. The brand-new Vera Rubin Observatory in Chile accidentally captured this object during equipment testing. When they combed through old data, they found 49 images of 3I Atlas from before anyone even knew it existed. These pre-discovery images revealed that strange backwards tail right from the start. The James Webb Space Telescope has been observing in infrared, potentially revealing heat signatures and identifying specific chemical compounds. NASA's TESS satellite, normally used for hunting planets around other stars, has been repurposed to monitor brightness changes over time. What if buried in all this data is evidence of something we've never seen before? Water ice, with a completely different chemical fingerprint than anything in our solar system? Dust, grains, that formed around a star 7 billion years ago? Scientists are particularly interested in measuring the deuterium to hydrogen ratio in any water ice they detect. This ratio acts like a fingerprint, telling us what kind of stellar environment the object formed in. If that ratio is wildly different from Earth's oceans, it would confirm that 3I Atlas formed in a completely different part of the galaxy under completely different conditions. The ancient messenger. What if this visitor is literally older than our entire solar system? Initial studies suggest 3I Atlas originated from the Milky Way's thick disk, a region populated by ancient stars. If true, this comet could be 7 billion years old. Our Sun is only 4.6 billion years old. Think about that. This object was already wandering through space for billions of years before our planet even existed, before the sun ignited, before anything in our neighborhood formed. It's like discovering a message in a bottle that was thrown into the ocean before your grandparents were born, before your country existed, before humans walked upright. What if trapped inside this ancient traveler are pristine samples of chemistry from the early Milky Way? Molecules and compounds that formed when our galaxy was young and chaotic? Materials that could tell us how planets formed around stars that died billions of years ago? This isn't just a comet. It's a time capsule from another era of cosmic history. The pattern of strangeness. What if 3I Atlas isn't an isolated mystery, but part of a pattern we're only beginning to recognize? Remember Oumuamua? In 2017, it shocked everyone with its cigar-like shape and unexplained acceleration as it left our solar system. Scientists still can't fully explain what propelled it. Normal comet outgassing didn't match the observations. Then came Borisov in 2019. It seemed more conventional at first, but then suddenly fragmented during its closest approach to the Sun in ways that surprised comet experts. Now, 3I Atlas presents even more anomalies. The backwards tail, the enormous size, the statistically improbable trajectory. No detectable gas emissions. What if each interstellar visitor we detect forces us to expand our understanding of what's possible? What if our models of interstellar space are fundamentally incomplete? We've only detected 3 of these objects. 3. That's not enough to build a comprehensive theory. We're like people who've only seen 3 animals in their entire lives, trying to write a biology textbook. What if the 4th, 5th, and 10th interstellar visitors show us things even stranger than what we've already seen? The military silence. Here's something interesting that might make you think. The United States Space Command operates sophisticated networks dedicated to monitoring objects in space. Their space fence system can track even small debris throughout our solar system with incredible precision. Yet despite 3I Atlas being potentially the largest interstellar object ever detected, traveling at unprecedented speeds on an unusual trajectory, we've heard remarkably little from military and defense organizations. What if they're watching very carefully, but staying quiet? From a planetary defense perspective, this visitor represents a perfect real-world test case. It's massive, moving extraordinarily fast, and following a path that brings it close to multiple planets. What if agencies are using 3I Atlas as an opportunity to run silent drills, testing detection systems, communication protocols, and decision-making frameworks without causing public alarm? If you're responsible for planetary defense, this is your nightmare training scenario. A fast, massive object from deep space that you couldn't intercept even if you wanted to. The technology simply doesn't exist yet to catch up to something moving 130,000 miles per hour. What happens next? We're approaching the crucial moment. Right now, in mid-November 2025, 3I Atlas is somewhere on the far side of the Sun, hidden from our view. In the coming weeks, it will re-emerge, and what we see then could answer everything, or deepen the mystery even further. What if it fragments into pieces as it swings around the Sun? A sudden breakup would reveal its internal structure and composition. We'd get a rare glimpse inside this ancient traveler. What if it suddenly releases a massive outburst of gases that were previously undetected? That would support the idea that it's a natural comet, just behaving strangely because of unusual composition. Or what if it sails through perihelion with no dramatic changes at all. That stability would suggest something more solid, less volatile than typical comets. Scientists are preparing every available telescope to capture what happens. NASA's Perseverance rover on Mars, the MAVEN orbiter, potentially even the Juno spacecraft near Jupiter, might capture unique perspectives when Earth's telescopes can't see it. The ancient question: what if 3I Atlas, regardless of what it turns out to be, is asking us a question? Are we paying attention? Are we ready to learn from what the universe sends our way? This 7-billion-year-old wanderer has traveled across unimaginable distances to reach us. In cosmic terms, it's just passing through. A fleeting encounter between our young solar system and a relic from another time and place. We have one brief window to study it, one chance to uncover its secrets. After that, it vanishes forever into the darkness between stars, never to return. What if inside this ancient visitor are answers to questions we haven't even thought to ask yet? Questions about how stars form, how planets develop, how chemistry evolves across billions of years, questions about what else might be drifting through the galaxy right now. The universe is vast beyond comprehension. What we've seen so far is like examining a single grain of sand and trying to understand an entire beach. 3I Atlas reminds us that space is stranger than we imagined, that our models are incomplete, that every time we think we understand how things work, something comes along that forces us to reconsider. The final mystery. In the next few weeks, as this visitor emerges from behind the sun, we'll finally get answers, or at least, we'll get more data. Sometimes in science, more data just means better questions. What if the backwards tail persists, stronger than ever? What if new jets of material appear that weren't there before? What if the object's brightness changes in ways that don't match any comet we've studied? Or, what if it turns out to be exactly what it appears to be at first glance? An ancient, unusual but perfectly natural comet carrying secrets from a star system that died billions of years ago? Either way, we're watching history unfold in real time. Whether 3I Atlas is the strangest comet ever detected or something more extraordinary, it represents humanity's best chance yet to study a messenger from beyond our solar system. The story isn't over, it's just beginning. And what if the real answer is something we haven't even considered yet? Something that forces us to rewrite our understanding of what travels between the stars? That's the beauty of genuine scientific mystery. We don't know what we don't know, but we're about to find out. Whatever 3I Atlas reveals in the coming days, one thing is certain. The universe still has the power to surprise us, to challenge us, to remind us that we're still at the beginning of understanding the cosmos. What if that's exactly the lesson we need right now? Stay curious. Keep watching the skies, because somewhere out there, racing through the darkness at 130,000 miles per hour, is an ancient visitor carrying secrets from a time before our world existed. And it's about to show us what it's been hiding.